Okay, in this video, we are going to use the dilution formula. So, what you found to dilute something is to add water to it to make it less concentrated. And so you want to lower the molarity by adding more solvent, more water to it. And so you're not adding any more solute, you're just adding more water. Well, we're going to use the idea behind that to set up our dilution formula. So we're not changing the number of moles, okay? But you start off with something that has a high concentration, and your goal is to lower the molarity by adding more water. So the mole stays the same. So notice that I have moles exactly the same, but then the molarity is labeled, the starting one is labeled M1, and the ending, which will be lower, is labeled M2. Our starting volume is L1, and then our ending volume is labeled L2, because it's going to have a larger volume because you're adding water to it. So since both of these have the same number of moles, what we can do is solve both of these equations for moles by multiplying by liters on both of them. I'm just going to draw a line right here so that we know where they're divided. Okay, and we'll see that our liters cancel out. And we are left with L1 times M1 is equal to moles. And on this side, moles is equal to M2 L2. Okay? So since they're equal to the same thing, both sides, we can set them equal to each other. So we end up with L1 M1 equals L2 M2. Now, so there's our dilution formula. Now, if I look at our problem, it says how many milliliters of 18 molar sulfuric acid, H2SO4, would I dilute to make 750 milliliters of a 2 molar H2SO4? So notice that these are in milliliters. Okay, they're asking for milliliters for the answer. Our ending volume, our L2, is already in milliliters. The nice thing about this formula is that if they give you milliliters, and they're asking you to end in milliliters, we do not have to convert. Okay, so you can think of it like this. Okay, so I can plug in my numbers that they gave us. I'm going to just label them really quickly. So starting concentration is the higher one. So that's M1. We're looking for L1. Okay, they gave us L2 or V2, and they gave us M2. So we just plug in those numbers into our formula. So V1 times 18.0 equals 750 milliliters times 2. Okay, so I plug that in. Now to get V1 all by itself on one side of the equation, what I'm going to do is divide both sides by 18 to get rid of it on the left. Okay, so I have 750 times 2 and then divided by 18. And I'm going to keep 3 sig figs because 750, see the decimal? That means this trailing 0 is counted. It has 3 sig figs, this has 3 sig figs, and this has 3 sig figs. So I'm going to keep 3 sig figs in our answer. And we end up with V1 equaling 83.3 milliliters. Okay, so what we would do is take the 18 molar, the strong sulfuric acid, we would add, we would take 83.3 milliliters of it, and we would add enough water to make a total solution of 750 milliliters. Okay, so let's practice another one using the same formula. So M1 V1 equals M2 V2. So if I look at my problem, I'm going to label things. I have concentrated, so this is our M1, our larger molarity. We're looking for V1. Okay, we have V2 and M2. So we plug in our information, 12 molar times V1 equals 0.25 molar times 500 milliliters. Okay, so now I divide both sides by 12 molar. Notice that my molarity cancels out on both sides. Okay, and I'm only left with milliliters, which is the volume, that measurement that I want. So 0.25 times 500 divided by 12. I'm going to keep 2 sig figs in this answer, and I end up with 10 milliliters. So I would take 10 milliliters of the concentrated HCl, the 12 molar, and I would add enough water so that my new volume was 500 milliliters. So that is talking about dilutions.